Alright, let's go. The Black Sea was not always a sea. Until approximately 7,600 years ago, it was a freshwater lake, calm, enclosed, surrounded by farmland. Then the natural dam holding back the Mediterranean gave way. What followed was a waterfall 200 times the volume of Niagara Falls, pouring salt water into the basin for 300 days. The lake swallowed 155,000 square kilometers of inhabited land. The people living there had no word for what was happening to them. Their settlements are still down there, under 300 feet of water, perfectly preserved in the anoxic depths, abandoned mid-meal. That flood is number 3 on this list. Number 10, the Missoula Floods. In 1923, a geologist named J. Harlan Bretz presented a paper to the Geological Society of America in Washington, D.C. He had spent years surveying a 16,000 square kilometer region of eastern Washington state, a landscape of dry waterfalls, gravel bars 200 feet tall, and canyon systems carved not over millions of years, but in a matter of days. He called it the channeled scablands. His explanation, a flood of incomprehensible scale had swept through this region within living memory of prehistoric humans. The geological establishment rejected him entirely. The prevailing view, uniformitarianism, held that geological features formed gradually over vast timescales. A catastrophic flood on that scale was considered mythology, not science. Bretz was ridiculed for 40 years. He was right. In 1940, glaciologist Joseph Pardee identified the source. A glacial lake, now called Lake Missoula, had formed behind an ice dam in the Clark Fork River in present-day Montana. At its maximum extent, Lake Missoula held approximately 2,100 cubic kilometers of water. That is more water than Lake Erie and Lake Ontario combined. When the ice dam failed, as it did repeatedly, at least 40 times between 15,000 and 13,000 BCE, the release was nearly instantaneous. Peak flow rate is estimated at 17 million cubic meters per second. That is approximately 40 times the combined discharge of every river on Earth. The flood raced across Washington state at 65 miles per hour, carving coulees 900 feet deep, depositing boulders the size of houses 50 miles from their origin, and reaching the Pacific Ocean within days. The wall of water was at times 300 meters high. It traveled fast enough that sediment was deposited in layers, not the gradual layers of normal geological time, but dozens of distinct layers compressed into a single flood event, stacked on top of each other like pages of a book. Here's where the standard explanation becomes insufficient. The Missoula floods were not a single event. They occurred at least 40 times, possibly as many as 80, over a period of 2,000 years. Each time, the ice dam reformed. Each time, the lake refilled. Each time, the dam failed again. The cycle repeated on timescales of 30 to 50 years. Humans were present in North America during these floods. The Clovis people, the earliest confirmed inhabitants of the Americas, arrived on the continent approximately 13,000 years ago. They moved through a landscape that was actively being catastrophically reorganized beneath their feet. Generations lived and died within the flood cycle. The floods were not ancient history to them. They were the weather. The channeled scablands cover an area the size of Ireland. They exist because of water that fell as snow thousands of years before the floods, accumulated in glacial ice, and then released in geological instants. The Columbia River today flows through a channel cut not over millions of years, but in approximately 72 hours during a single flood event. J. Harlan Bretz was awarded the Penrose Medal, geology's highest honor, in 1979. He was 96 years old. He had spent 56 years being told he was wrong. The truly disturbing aspect of the Missoula floods isn't their scale. It's the rhythm. Ice dam, lake, dam failure, flood, repeat, 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 40 times or more. The people living downstream had no mechanism to understand this cycle. No written record, no geological framework, no way to know that the ground beneath them had been catastrophically rewritten dozens of times before they arrived, and would be rewritten again. The last of the Missoula floods occurred approximately 13,000 years ago. The ice that fed them is gone, but ice dams still exist. Glacial lakes still fill behind them. The mechanics that produced 40 catastrophic floods in the Pacific Northwest are not geological relics. They are current conditions. Number 9, the Zanclean Flood. In 2009, geophysicist Daniel Garcia Castellanos at the Spanish National Research Council published a paper in the journal Nature. The paper described in precise quantitative terms an event that had occurred 5.33 million years ago. It was not archaeology, it was not human history. But what Garcia Castellanos described was the largest flood in the geological record. And it happened to an ocean. 5.5 million years ago, the Mediterranean Sea dried out. This is not metaphor. The Messinian salinity crisis, as it is known, began when tectonic movement closed the connection between the Atlantic and the Mediterranean. The Mediterranean, largely enclosed and evaporating faster than rainfall could replenish it, shrank, and eventually, almost entirely, vanished. What remained was a series of hypersaline lakes at the bottom of a basin kilometers below sea level. The salt deposits left behind are in some places 3 kilometers thick. They are still there, visible in seismic surveys of the Mediterranean seafloor. Then, 5.33 million years ago, the barrier at what is now the Strait of Gibraltar was breached. Garcia Castellanos calculated the flow rate. At peak, approximately 100 million cubic meters of Atlantic water per second poured into the basin. For comparison, the Amazon River, the largest river on Earth by volume, discharges approximately 200,000 cubic meters per second. The Zanclean flood, at its peak, carried the equivalent of 500 Amazon rivers simultaneously. The Mediterranean refilled. Current estimates suggest this occurred over a period of anywhere from a few months to several thousand years. The rate depended on how quickly the breach widened. Garcia Castellanos' modeling suggests a rapid breach. The initial opening may have been less than 200 meters across, but the force of water eroding softer rock widened it rapidly. The waterfall that initially formed at Gibraltar would have been the largest on Earth by an order of magnitude. The implication here requires a specific restatement because there are no humans in this story. The Zanclean flood preceded Homo sapiens by 5 million years. But here's where the story becomes relevant. The Mediterranean basin is the birthplace of every Western civilization that followed. Rome, Greece, Carthage, Egypt, Phoenicia. The entire cradle of recorded history sits inside a geological feature defined by the largest single flood in the planet's recent geological record. The basin these civilizations occupied exists because an ocean evaporated and then refilled. The salt deposits still sitting 3 kilometers beneath the Mediterranean floor are the direct evidence. When ancient sailors navigated these waters, they were navigating a body of water that had ceased to exist 5.5 million years before them, and then came back. The present-day implication is structural. The Mediterranean is not a stable permanent feature. It is a transient condition maintained by the narrow connection at Gibraltar, a connection that is currently being narrowed by the same tectonic forces that closed it before. Not on a human timescale, but the forces are active. What Garcia Castellanos' paper established, in a peer-reviewed journal without controversy, is that floods do not require rivers. They do not require rain. They require only a barrier, a differential, and time. The Mediterranean provided all three, twice. Number 8, Meltwater Pulse 1A. In 1989, oceanographer Wallace Broecker at Columbia University proposed a mechanism he called the Ocean Conveyor Belt, a system of deep Atlantic circulation driven by temperature and salinity gradients that regulated climate across the entire northern hemisphere. Broecker spent the next 3 decades refining the model and identifying the conditions under which it could stop. One of those conditions was meltwater. Approximately 14,600 years ago, global temperatures began rising rapidly. The trigger was a shift in Earth's orbital geometry. The planet was receiving more solar energy in the northern hemisphere during summer. The ice sheets that had covered much of North America, Europe, and Asia for 20,000 years began to destabilize. And then, in a geological instant, they released. Meltwater Pulse 1A is the term applied to a discrete sea level rise event that occurred between approximately 14,650 and 14,300 years ago. In those 350 years, global sea level rose by between 16 and 25 meters. The source, whether primarily from the Antarctic ice sheet or the Laurentide ice sheet over North America, remains a subject of active scientific debate. The volume is not in dispute. 20 meters of sea level rise in 350 years averages to approximately 5.7 centimeters per year. In the context of current climate projections, in where 2 meters of rise by 2100 is considered a catastrophic scenario, this number requires restatement. Meltwater Pulse 1. A produced sea level rise at a rate roughly 30 times faster than current worst-case projections. It produced that rate not for a decade, but for 3.5 centuries. Every coastline on Earth in 14,650 BCE was obliterated. Here's where the implication becomes disturbing. Humans had been living on those coastlines for thousands of years before Meltwater Pulse 1A. The earliest known settlements we have found and dated are consistently inland. This is not coincidence. It is the result of a systematic sampling bias in the archaeological record. Every coastal site from before 14,600 years ago is now underwater, not eroded, not disturbed. Underwater, sitting on continental shelves around the world, sealed beneath meters of marine sediment, unexcavated and largely uninvestigated. The people who lived in those coastal settlements, their populations, their cultures, their languages, their technologies, are invisible to us. The flood did not destroy them immediately. It displaced them. The 5.7 centimeters per year that the sea rose was, on a human scale, perceptible within a single lifetime. People who were born on the coast died miles inland. Their grandchildren's grandchildren were born on a new coast. The original shoreline was, within a few generations, simply gone. We do not know how many people this erased. We cannot know. The evidence is on the continental shelf, under marine sediment, in water too deep for conventional archaeology to easily access. The handful of underwater archaeological sites that have been investigated: Pavlo Petri, off the coast of Greece, the submerged forests of the North Sea, the drowned structures off the coast of India near Dwarka, are consistent in what they show. People were living on those coastlines, and the coastlines disappeared. The truly disturbing aspect of Meltwater Pulse 1A is not the 20 meters. It's the question it forces. If 3.5 centuries of coastal flooding could erase this much of the human record, what did the longer, slower, cumulatively larger sea level rise of the past 20,000 years erase in total? Since the peak of the last ice age approximately 20,000 years ago, global sea levels have risen by approximately 130 meters. That is 130 meters of continental shelf, worldwide, now underwater. The total area of land submerged since the last glacial maximum is estimated at approximately 27 million square kilometers, roughly the combined land area of North America and Europe. Whatever was on that land is now on the seafloor. Number 7, the Storegga Slide. On the floor of the Norwegian Sea, approximately 80 kilometers northwest of the city of Trondheim, there is a scar in the continental shelf. It is 290 kilometers wide at its mouth and extends 800 kilometers down the slope of the seabed. It is the remnant of one of the largest submarine landslides in recorded geological history, and it generated a tsunami that struck the inhabited coastlines of northern Europe approximately 8,200 years ago. The Storegga Slide occurred when an area of accumulated sediment on the Norwegian continental margin, a mass of material roughly the volume of Iceland, destabilized and collapsed into the deep ocean. The volume of material displaced was approximately 3,500 cubic kilometers. The speed of the collapse generated a series of tsunami waves that propagated across the North Sea in every direction. Geologist David Smith at Coventry University and colleagues reconstructed the wave heights from marine sediment deposits found far inland along the Scottish coast. At the Shetland Islands, the tsunami reached a height of approximately 20 meters. On the mainland Scottish coast, deposits indicate waves of 3 to 6 meters. In Norway itself, run-up heights of 10 to 12 meters have been documented. The tsunami crossed the North Sea and left evidence as far south as the coast of Denmark. Here's where the human costs become specific. In 6,200 BCE, the coastline of Scotland was inhabited. Mesolithic hunter-gatherers had been living along British coasts for thousands of years since the glaciers retreated. Their settlements were coastal. Shell middens, fish camps, seasonal occupation sites on the beaches and river mouths. The Storegga tsunami arrived without warning on a coastline, with no elevation to retreat to in many areas. No Mesolithic settlement has been found on the Scottish coast, datable to immediately after 6,200 BCE at the tsunami-affected elevations. The absence is the evidence. The Storegga Slide is also significant for what it accelerated. The event occurred at approximately the same time as the final stages of Doggerland's submersion. The tsunami, sweeping across the North Sea, struck a landscape that was already disappearing. The low-lying land bridge that still partially connected Britain to continental Europe would not have survived a 10-meter wave. Whatever remained of Doggerland's coastal settlements after the slow sea level rise of the preceding millennia was almost certainly swept clean by the Storegga event. What makes this particularly unsettling is the mechanism. The Norwegian continental shelf today still contains large volumes of sediment accumulated since the Storegga Slide. The same glacially derived sediment that destabilized 8,200 years ago has been slowly rebuilding on the same slopes. Gas hydrates, frozen methane compounds that may have contributed to the original failure by destabilizing the sediment, are present throughout the region. The Norwegian Geotechnical Institute has been monitoring the continental margin for exactly this reason. The question the Storegga Slide raises is not whether similar events can occur again. It is whether the sediment conditions that produced the original failure are being recreated by the same geological processes. The monitoring continues. The sediment accumulates. The coasts of Scotland, Norway, and Denmark that were struck by 20-meter waves in 6,200 BCE are today home to a combined population of approximately 16 million people. Number 6, Doggerland. In 1931, the fishing trawler Calinda was dragging nets through the North Sea approximately 40 kilometers off the coast of Norfolk, England, at a depth of about 35 meters. The nets brought up a lump of peat. Inside the peat was a harpoon made from bone, barbed on one side, approximately 22 centimeters long. It was Mesolithic, roughly 11,500 years old. The harpoon had not fallen off a boat, and it had been left on the ground by a person standing on land that was no longer land. The region archaeologist Bryony Coles named Doggerland in 1998. After the Doggerbank, a shallow area of the North Sea, was a landmass of approximately 250,000 square kilometers at its maximum extent during the last glacial maximum. It connected Britain to continental Europe across what is now the North Sea basin. At its peak, it was larger than modern-day Great Britain. It was not tundra or barren glacial plain. By the Mesolithic period, roughly 10,000 to 5,000 BCE, it was a richly productive landscape of rivers, lakes, wetlands, and coastal marshes. Archaeologist Vince Gaffney at the University of Bradford spent years analyzing three-dimensional seismic survey data, originally collected by oil companies, exploring the North Sea. What he found was the shape of a drowned world. River channels, lake basins, coastlines preserved in the sediment. By 2009, his team had produced the most detailed map of Doggerland ever created, a landscape of extraordinary productivity, comparable in ecological richness to the Nile Delta. The human inhabitants of Doggerland were Mesolithic hunter-gatherers. They had lived there for thousands of years since the glaciers retreated. Fishing trawlers have recovered their artifacts for over a century. Stone tools, wooden objects, animal bones, the occasional piece of human bone. One particularly striking find, a human skull recovered by trawlers operating off the Dutch coast, radiocarbon dated to approximately 9,000 years ago. Here's where the implication becomes precise. Doggerland did not disappear in a single event. It was consumed gradually, by meltwater pulse 1A, by the continuing post-glacial sea level rise, by the Storegga tsunami, over approximately 5,000 years. A landmass the size of Great Britain was reduced to a series of islands, then to the Dogger Bank, now a shallow underwater ridge, and finally to nothing visible above the surface of the North Sea. The population that lived in Doggerland didn't go extinct, they moved. North Sea coastlines receded as Doggerland shrank, and the people moved with them, into Britain, into Denmark, into the Netherlands. The genetic contribution of Doggerland's Mesolithic inhabitants to modern European populations is not zero. It is simply unquantifiable, because we do not know how many people lived there, how complex their social structures were, or how much of their cultural knowledge survived the displacement. What was permanently lost is the archaeology. Doggerland's sites are not merely inaccessible, they are obscured. The North Sea seabed is dynamic. Sediments shift. Artifacts are exposed and reburied by tidal currents. The sites that fishing trawlers occasionally disturb are not being systematically excavated. The resources required for underwater archaeology at North Sea depths, which range from 20 to 100 meters, are substantial. The truly disturbing aspect of Doggerland is not its size, it's the timeline. The people who watched Doggerland disappear did not watch it happen in a century. They watched it happen over 5,000 years. Their grandparents' fishing grounds became open water. The islands they could see from their coast shrank and disappeared within their children's lifetimes. Entire cultural geographies, sacred sites, burial grounds, places with names, went underwater with no record and no memorial. Somewhere in the North Sea, at depths between 20 and 100 meters, there are Mesolithic sites as significant as any that have been excavated on land. We have no serious program to find them. Number 5. Sundaland. At the peak of the last ice age, approximately 20,000 years ago, so much of the planet's water was locked in glacial ice that global sea levels were roughly 120 meters lower than today. In most parts of the world, this meant coastlines extended somewhat further out to sea. In Southeast Asia, it meant something more dramatic. The continental shelf of Southeast Asia is extraordinarily shallow. At a sea level 120 meters lower than today, the Sunda Shelf, in which now lies beneath the waters of the Java Sea, the South China Sea, and the Strait of Malacca, was dry land. The islands of Borneo, Java, Sumatra, and the Malay Peninsula were not islands. They were a single connected landmass, approximately 1.85 million square kilometers in area. That is roughly the size of India. Geologists call it Sundaland. It existed as a largely continuous landmass for at least several 100,000 years, only submerging as sea levels rose after the last ice age. At its maximum during the coldest periods of the Pleistocene, it was one of the largest landmasses in the tropical zone. Its rivers, the predecessors of the Mekong, the Irrawaddy, the Chao Phraya, drained into a central basin that is now the shallow floor of the Java Sea and the Gulf of Thailand. In 1998, geneticist Stephen Oppenheimer published a book titled Eden in the East. Drawing on mitochondrial DNA studies of populations across Southeast Asia and the Pacific, Oppenheimer argued that Sundaland had been a major center of human habitation and cultural development before its submersion, and that the flood migrations from Sundaland had seeded populations across mainland Asia and the Pacific Islands. His genetic data suggested that the apparent origins of agricultural and maritime technology in the region followed the flooding of Sundaland rather than predating it. Here's where the implication deepens. Modern archaeology places the origins of agriculture independently in several locations: the Fertile Crescent, China, the Americas. But the genetic and linguistic evidence in Southeast Asia shows patterns consistent with a rapid dispersal event. A population pushed rapidly outward from a central point within the past 10,000 years. Sundaland's submersion timeline coincides precisely with this dispersal. The seafloor of the Sunda Shelf has been surveyed only partially. What surveys have been done reveal river channels, lake basins, and coastal features, consistent with a rich, productive, heavily habitable landscape. No systematic archaeological excavation of the Sunda Shelf has been conducted. The water depths, ranging from 20 to 120 meters across the shelf, make such work logistically demanding. The political jurisdictions the shelf lies across multiple national boundaries make coordination difficult. What may be lying on the Sunda Shelf floor is not merely Mesolithic campsites. If Oppenheimer's thesis is correct, and the genetic evidence has been reinforced, not refuted, by subsequent studies, what lies on the Sunda Shelf is the archaeological record of a formative period in human cultural development. Not hunter-gatherer camps, something more complex. The truly disturbing aspect of Sundaland is the scale of what we are not looking for. Marine archaeology has produced extraordinary results in the Mediterranean and Black Sea, where water depths are manageable and institutional interest is high. The Sunda Shelf remains effectively untouched. 1.85 million square kilometers of formerly inhabited tropical lowland, containing potentially tens of thousands of years of human occupation. The last portion of Sundaland disappeared beneath the rising sea approximately 6,000 to 7,000 years ago. Whatever the people living there built, believed, or knew went with it. Number 4, the 8.2 Kilo-year event. At its maximum extent, approximately 13,000 years ago, Lake Agassiz was the largest lake in the history of North America, and possibly the largest lake that has ever existed on Earth. It covered an area of approximately 1.5 million square kilometers spread across what is now Manitoba, Ontario, Saskatchewan, and portions of the northern United States. It was fed by glacial meltwater and held behind a natural dam of ice, the retreating Laurentide ice sheet. It drained in an event that lasted, by current estimates, approximately 9 months. In approximately 6,200 BCE, the ice dam that had been holding Lake Agassiz from the Hudson Bay drainage system failed. The lake, combined with the adjacent Lake Ojibwe, discharged approximately 163,000 cubic kilometers of freshwater into the North Atlantic Ocean through Hudson Bay. That is roughly twice the volume of the modern Black Sea. The immediate physical effect was geological, but the secondary effect, the one that reaches across hemispheres, was climatic. In 1997, paleoclimatologist Peter Domenical at Columbia University and colleagues published analysis of marine sediment cores from the North Atlantic showing a distinct cooling signal at approximately 8,200 years ago, so a layer of freshwater-borne material from exactly the direction of Hudson Bay. The freshwater pulse from Lake Agassiz had disrupted the thermohaline circulation, the Atlantic Ocean current system that regulates temperature across the northern hemisphere. Ocean surface temperatures in the North Atlantic dropped by up to 3 degrees Celsius within decades. Global temperatures cooled by 1 to 3 degrees Celsius. The cold period lasted approximately 160 years. Here's where the human cost becomes specific and disturbing. The 8.2 Kilo-year event did not occur in a wilderness. It occurred in the middle of the Neolithic agricultural revolution. Farming communities had been established in the Fertile Crescent for 2,000 to 3,000 years by 6,200 BCE. The Vinca culture in southeastern Europe was producing complex, settled societies. Çatalhöyük in central Anatolia, one of the earliest large urban settlements ever found, had a population of several thousand people. Harvey Weiss at Yale University and colleagues have documented evidence of widespread disruption in farming communities across the Middle East and Europe at precisely the 8,200-year mark. Settlements show population decline or abandonment. Agricultural activity drops. Evidence of drought appears in lake sediment cores from Syria, Turkey, and the Levant simultaneously. The disruption was not caused by the flood directly. It was caused by the climate cascade the flood triggered. A pulse of freshwater into the North Atlantic slowed the Atlantic circulation, cooled the climate, altered rainfall patterns, and starved agriculture across multiple continents, all within approximately 50 years of the Lake Agassiz failure. Çatalhöyük was partially abandoned during this period, then reoccupied. The Vinca culture shows disruption. Early farming communities in Syria and the Levant contracted or disappeared entirely. The connection between a glacial lake draining in North America and crop failures in the Middle East 3 centuries later is not metaphor. It is mechanism. The truly disturbing aspect of the 8.2 Kilo-year event is the efficiency of its reach. A single geological event, an ice dam failure in Hudson Bay, disrupted agricultural societies across at least 3 continents within a human lifetime. The people growing wheat in Syria in 6,200 BCE had no knowledge of North America. They had no mechanism to understand what was cooling their growing season. They simply watched their harvests fail. The Lake Agassiz Basin is now the Canadian prairies. The ice that held it is gone. But the mechanism, freshwater pulses disrupting Atlantic circulation, is currently being studied in the context of present-day Greenland ice melt. The Atlantic meridional overturning circulation is currently at its weakest point in the past 1,000 years. Oceanographers are watching it with the same attention Broker brought to the question in 1989. The question the 8.2 kilo-year event answers is whether such disruptions are possible on the timescale of a human civilization. It answers that question definitively. They are not merely possible, they have happened. Number 3. The Black Sea Deluge. In 1997, marine geologists William Ryan and Walter Pittman at Columbia University's Lamont Doherty Earth Observatory published a paper in Marine Geology proposing a mechanism for one of the most significant flood events in human prehistory. 3 years later, explorer Robert Ballard, who had found the Titanic, deployed remotely operated vehicles to the Black Sea floor and found something that confirmed their hypothesis. He found houses. Ryan and Pittman's thesis began with the geology. At the end of the last ice age, the Black Sea was not a sea. It was a large, freshwater lake, fed by rivers, isolated from the Mediterranean by a land bridge at what is now the Bosphorus Strait in Turkey. As glaciers melted across the northern hemisphere, the Mediterranean rose. But the Black Sea basin, fed primarily by river runoff from glacial meltwater that was decreasing as the ice retreated, was actually dropping in level. The land bridge at the Bosphorus held until approximately 5,600 BCE. At that point, Ryan and Pittman calculated, the Mediterranean had risen sufficiently that it overtopped the Bosphorus sill. The breach, once begun, widened rapidly. The rate of water entry into the Black Sea basin they estimated at approximately 10 cubic miles per day, the equivalent of 200 Niagara Falls. The water would have been audible for kilometers. It would have been visible, a moving wall of salt water, for tens of kilometers. The freshwater lake rose by roughly 15 to 20 centimeters per day during the initial breach. The shoreline moved at a rate that, in the flat coastal plains surrounding the lake, would have been perceptible within weeks. Villages that had sat on the lake shore became lakefront property overnight, then shallow water, then open sea. Approximately 155,000 square kilometers of arable land was inundated. The Black Sea Basin in 5,600 BCE was not wilderness. It was inhabited. The mild climate, the freshwater lake, and the surrounding river valleys had supported farming settlements for at least 2,000 years before the flood. These were Neolithic communities, people who grew grain, kept domesticated animals, lived in permanent structures. Robert Ballard's 2000 expedition found the first direct physical evidence. At a depth of approximately 95 meters in the southern Black Sea, his ROVs documented wooden structures, collapsed but present, along with stone tools, ceramics, and what appeared to be worked timbers. The site was consistent with a Neolithic settlement that had been rapidly submerged and then sealed in the anoxic conditions of the deep Black Sea, which preserves organic material indefinitely. Here's where the implication becomes significant beyond archaeology. The Ryan-Pittman flood hypothesis has been proposed as a possible origin for the Noah's Ark narrative and related flood mythology, the Epic of Gilgamesh, the Babylonian flood story, and the Genesis account. The flood described in these texts shares specific features with the Black Sea event. A freshwater environment turned to saltwater, a large flood with a definite beginning, the survival of specific people who escaped to higher ground, the gradual retreat of water. The geographic overlap is exact. The cultures that produced the flood narratives, Sumerian, Babylonian, Hebrew, occupied the river valleys northeast and southeast of the Black Sea basin. The refugees from the Black Sea flood, if the Ryan-Pittman model is correct, moved into exactly those regions. They may have brought the story with them. The truly disturbing aspect of the Black Sea deluge is not the flood itself. It's what the flood buried. The Black Sea floor is anoxic below approximately 200 meters. Nothing decays there. The wooden structures Ballard found in 2000 had been sitting in the cold, oxygen-free water for 7,600 years. They were not ruins, they were preserved. Whatever else is on the floor of the Black Sea, and 155,000 square kilometers of formerly inhabited land is a significant archaeological target, has been sitting in those same conditions for the same amount of time. We have excavated almost none of it. Number 2, the Persian Gulf Oasis. In 2010, archaeologist Jeffrey Rose at the University of Birmingham published a paper in the journal Current Anthropology. The paper proposed an explanation for one of the most persistent puzzles in the archaeology of human origins. Why, between approximately 50,000 and 60,000 years ago, the archaeological record of the Arabian Peninsula shows evidence of a significant, sophisticated human population, and then shows almost nothing for thousands of years. And then, around 7,500 years ago, shows the abrupt, apparently sourceless emergence of Ubaid culture in Mesopotamia. Rose's explanation: the missing people were living on the floor of the Persian Gulf. During ice ages, when global sea levels were substantially lower, the Persian Gulf basin was not a gulf. It was a river valley, fed by the combined flow of the Tigris, Euphrates, Karun, and Wadi Batan rivers, all draining toward the Strait of Hormuz. At sea levels 120 meters lower than today, the entire present-day floor of the Persian Gulf was dry land. At the lowest sea levels, the exposed basin covered approximately 800,000 square kilometers. Rose called this valley the Persian Gulf Oasis. It was, he argued, one of the most favorable environments for human habitation anywhere in the world during the Pleistocene. The river valley at the center of the basin would have provided fresh water, fertile soil, and a stable food supply in a region surrounded by increasingly arid desert. As the last ice age intensified across the Arabian Peninsula, reducing rainfall, expanding desert, the river valley at the center of the Persian Gulf would have acted as a refuge. Populations that could no longer survive on the surrounding plateau would have concentrated in the valley. The genetic evidence is consistent with this model. Population genetic studies of Arabian Peninsula and South Asian populations show patterns consistent with a bottleneck, a period of reduced population, followed by rapid expansion approximately 8,000 to 10,000 years ago. The timing matches the period during which the Persian Gulf was refilling. Here's where the implication becomes historically significant. As sea levels rose after the last ice age, the Persian Gulf Oasis did not flood abruptly. It filled gradually, the shoreline moving inland at a rate measurable in human lifetimes. The people living in the basin would have had decades, perhaps centuries, to observe the rising water. They would have migrated, not in a single exodus, but in successive waves, moving up the Tigris and Euphrates valleys into Mesopotamia as the water claimed the land behind them. The Ubaid culture, the immediate predecessor of Sumerian civilization, appears in the archaeological record of southern Mesopotamia at approximately 6,500 BCE, with no clear local antecedent. It was sophisticated from its first appearance. Mud brick architecture, painted pottery, evidence of social stratification, irrigation agriculture. It appeared in the archaeological record almost fully formed. Jeffrey Rose's hypothesis: the Ubaid people were refugees. They were the population of the Persian Gulf Oasis, people with thousands of years of accumulated cultural and technological development, who had been pushed by rising water into Mesopotamia. They did not arrive as Stone Age nomads. They arrived with everything they had learned during their time in the oasis. If Rose is correct, then the civilization we call the first, Sumerian, Mesopotamian, the foundation of all Western history, was not a beginning. It was a relocation. Chapter 1 of the story we know was actually Chapter 2. Chapter 1 is sitting under the Persian Gulf at depths between 40 and 120 meters, waiting to be found. The Persian Gulf floor has not been archaeologically surveyed. The political complexity of the region, the floor of the Gulf, lies within the jurisdictions of Iran, Iraq, Kuwait, Saudi Arabia, Bahrain, Qatar, the United Arab Emirates, and Oman, makes international coordination for systematic survey logistically challenging. No systematic archaeological survey of the Gulf floor has been conducted. The truly disturbing aspect of the Persian Gulf Oasis hypothesis is the implication for everything downstream. If the founders of Sumerian civilization were refugees from a drowned world, what did they carry with them? What traditions, what knowledge, what memory of their homeland did they encode in the written records they eventually left us? The world's oldest literature, the world's oldest legal codes, the world's oldest cosmologies. And what remains in the sediment of the Gulf floor that could answer that question? Unexcavated, preserved in the cold water, waiting. Number 1, Meltwater Pulse 1b and the Total Reckoning. In the summer of 2002, a team of researchers at Oregon State University and the Australian National University published a paper in the journal Science. The paper, led by geoscientist Peter Clark, analyzed oxygen isotope records from deep-sea sediment cores collected across the Pacific and Atlantic Oceans. What the cores showed was a discrete acceleration in sea level rise that had occurred approximately 11,500 years ago, immediately after the cold period known as the Younger Dryas ended. They called it Meltwater Pulse 1b. The numbers are approximate and still debated, but the most widely cited estimates suggest that during Meltwater Pulse 1b, global sea levels rose by at least 10 to 15 meters over a period of roughly 1,000 years. This was not as rapid as Meltwater Pulse 1a's 20 meters in 350 years, but it occurred at a more consequential moment. It occurred at the precise boundary between the Pleistocene and the Holocene, the period during which every civilization in recorded history has existed. 11,500 years ago is not geological prehistory. In 9,500 BCE, humans had been anatomically modern for 200,000 years. They had been behaviorally modern, with language, symbolic thought, art, ritual, for at least 40,000 years. In the Levant and Anatolia, and in Mesopotamia, the first experiments with systematic plant cultivation were underway. In other parts of the world, sophisticated hunter-gatherer cultures had been in existence for millennia. The world in 9,500 BCE was not empty. It was occupied, by coastal people in particular. Meltwater Pulse 1b submerged the world that those people had been building for thousands of years. It did not do so overnight. It did so over roughly 1,000 years, 10 generations, at a rate of 1 to 1.5 centimeters per year on average, with episodic rapid pulses superimposed on the baseline. The coastlines of 9,500 BCE receded. They were replaced by new coastlines. Those new coastlines receded in turn. The process repeated until sea levels stabilized at approximately their current position around 7,000 years ago. Now consider what this means in aggregate. From the peak of the last ice age, 20,000 years ago, to the sea level stabilization of 7,000 years ago, global sea levels rose by approximately 130 meters. This occurred not in a single pulse, but through a series of accelerations over 13,000 years. During those 13,000 years, every generation of coastal humans on Earth was born on a shoreline that did not exist when their grandparents were born. The total area of land submerged is approximately 27 million square kilometers. This is the area of land that was above sea level at 20,000 years ago, but is now beneath the ocean. It includes the entire North Sea basin where Doggerland existed, the Sunda Shelf where Sundaland existed, the Persian Gulf basin where Rose's Oasis existed, continental shelves worldwide at depths varying from a few meters to 130 meters, depending on their original elevation. Every one of those 27 million square kilometers was potentially habitable during the period it was above sea level. We do not know what was built on it. We cannot know, without systematic investigation, how much of our prehistory, how many cultures, how many technologies, how many population centers has been sitting since 7,000 BCE on the floors of the world's oceans invisible to land-based archaeology. Here's where the standard dismissal falls apart. The argument typically made is that pre-agricultural peoples would not have built anything permanent enough to preserve. The Black Sea disproves this. Wooden structures from 7,600 years ago are sitting on the Black Sea floor intact, preserved in anoxic water. The Persian Gulf at sufficient depth has similar anoxic conditions. Stone tools do not decay. Neither do ceramics. Neither do the geomorphological traces of human landscape modification, agricultural terracing, canal systems, midden accumulations, that are visible in shallow water surveys where they have been attempted. The truly disturbing aspect of this accounting is not what was lost. It is what we are not looking for. The entire history of underwater archaeological investigation, since Jacques-Yves Cousteau, has focused overwhelmingly on shipwrecks, vessels lost in historically documented waters, at relatively shallow depths. The prehistoric coastal settlements now sitting on continental shelves worldwide represent a different category of underwater heritage entirely, and they have received proportionally almost no systematic attention. Since the stabilization of sea levels approximately 7,000 years ago, human civilization has built everything we call history, writing, cities, empires, religions, science. All of it happened in the last 7,000 years. All of it happened on land that the sea had just finished reorganizing. The people who built the first cities in Mesopotamia and the Indus Valley in Egypt did so as the inheritors of coastlines that had moved 130 meters upward within the previous 13,000 years. They were not starting from nothing. They were starting from a displacement, error. What meltwater pulse 1b represents, in the broadest sense, is not a single flood event. It is a threshold, the moment at which the sea levels that define the world we know were established. Everything before that threshold, every human settlement, every cultural development, every coastline-based civilization is on the other side of 130 meters of water. The question the geological record is asking is not where human civilization began. It is where else it was already. If you want to see more videos like this, click the video on screen now and make sure to subscribe.